Alrighty. Today we are going to review for our inverse function unit. Okay. And so we want to, on numbers 1 and 2, we're asked to evaluate each function. Okay, so evaluate the function means it's giving you a function here, and then it's telling you what it wants you to plug in to that function. So first we started with f of x, then it's telling us plug 0 in to that x spot. Okay, so then this becomes 4 to the power of 0 minus 1. Okay, and this one's actually a pretty challenging question. This one, there won't be one as challenging as this on your test. Okay, so 4 to the power of 0 minus 1, well, this becomes 4 to the negative first power. Okay, and then we have to remember with a negative exponent, so this is taking us back to our exponent rules, it grabs its base and it moves to the bottom of the fraction. So this becomes 1 is left on top over 4 to the power of 1, or just 4. So final answer, 1/4. All right, number 2. Okay, so again, it's giving us our function, kind of a long function, g of x. Then it says plug in -1 everywhere you see an x. Okay, just right there. Okay, so I have the negative absolute value of -2 times -1, because we plugged it in for the x spot, plus 3, all in the absolute value, plus 1 on the outside. Okay, well, we treat absolute values like parentheses where we have to solve what's inside first. Okay, so -2 times -1 is +2. Okay, this is the absolute value of 2 plus 3, which is 5. Okay, well, the absolute value of 5 is just +5. Remember, whatever inside it just is positive, so it's already positive, so it stays +5. Okay, so then I'm going to rewrite this over here. We have negative now in front of that 5 from right there. And we just need to add that +1 on the end. Okay, so now we can go ahead and figure out what this is. -5 plus 1. It's going to give me -4. Okay, beautiful. Number 3 and 4, it's asking us to perform the indicated operation, which it just means you're either going to add, subtract, multiply, divide. Okay, so in these guys, it gives you 2 functions. Okay, so g of n is my top guy. H of n is my bottom guy, and it wants us to divide these guys. Okay, so we can see here that it's actually asking us to divide these 2 functions. Okay, so it wants g of n on top, so we'll put n plus 5, and it wants h of n on bottom. Okay, and that's as far as I'm going to actually have you guys simplify. Okay, so that's totally fine with me to just leave it like that. All right, number 4. We have our h of a function, top guy, and we have our g of a, and it's asking us to add these 2 functions together. Okay, so first I have my h of a, -4a plus 1. Then I'm going to add my g of a squared minus 5a. And so all we need to do when adding these guys together is simplify by combining like terms. So I can combine a's with a's, -4a and -5a. Remember, I can't combine it with a squared because it has to have the same variable but also the same power. Okay, so I can combine these two. -4 and -5 is going to give me -9a. A squared can't combine with anything. I'm going to put him in front because it's because of descending order. And the +1 on the end. So final answer, a squared minus 9a plus 1. And there we go. Okay, so it says sketch the graph of each line, then graph its inverse function. Okay, so that's going to be an important step. So the first thing we want to do is graph our original function. This guy is in slope-intercept form, which makes it kind of easy. We can identify slope and our y-intercept for our original function. Okay, our slope is always in front of our x, so we have -2, y-intercept of -3. Okay, remember we always start with our y-intercept. That's our starting point. Okay, so we find -3 on our y-axis, right there. And then our slope is -2, or if you wanted to do -2 over 1 to help you with rise over run, you could do that as well. So now we're going to go down to 1, 2 over 1. Okay, you only need 2 points to connect a straight line. So there's our original equation. And now we need to graph its inverse. Okay, so remember, when graphing the inverse, you simply switch the coordinate points. Okay, so you have your coordinate points of x comma y. You just switch them, or it becomes y comma x. Literally just switch places. Okay, so let's go ahead and identify what these coordinate points are. This one is 0, down 3. It's our y-intercept, so 0, comma, -3. This guy is 1, comma, -5. So 1, -5. So now in order to graph the inverse, you literally just switch them. Instead of 0, comma, -3, this becomes -3, comma, 0, which is right there. Instead of 1, comma, -5, it becomes -5, comma, 1, right there. And there is our inverse. Okay, so you can kind of see, if I kept the purple one going, that they're kind of reflections of each other, opposites. Okay, so let's go ahead and do that again. So for number 6, again, this guy's written in slope-intercept form, so we can identify our slope and our y-intercept. Slope is always in front of the x, -6. Y-intercept, +3. Okay, so I'm going to find my y-intercept on my y-axis, +3. I have a slope of -6, so now I'm going to go down 6, 1, 2, 3, 4, 5, 6 over 1. My line needs to be going down and to the right for a negative slope. Not the straightest line, but that's okay. Okay, now in order to graph its inverse, we identify the coordinate points. This one is 0, comma, 3. This one is 1, -3. Remember, it's always listed as the x coordinate, then the y coordinate, so 1, -3. And we just switch these. Instead of 0, comma, -3, it's going to be 3, comma, 0. Instead of 1, comma, -3, it's going to be -3, comma, 1. And same thing, you can see that kind of reflection opposite of each other. So there is its inverse. You literally just flip those coordinate points. Okay, awesome. Let's go to the back side of your notes. Okay, so we're still graphing the function and its inverse. In fact, I'll put that direction on your notes. And the inverse. Okay, so these guys are quadratics. Okay, we know it's a quadratic because of the power of 2. And they are written in vertex form, which is nice because our vertex, if we remember, is always -h, excuse me, comma k. Got to change the sign on the h. Okay, and remember vertex, we have our a in front of the parentheses. In this case, it's the invisible 1. H is the number inside the parentheses. K is the number on the end. Okay, so from here, we can identify our vertex for our original equation. Let me just zoom out a little bit. Okay, so our vertex, stop shaking, okay. Change the sign on the H, so this was -2, it becomes +2. Keep the sign on the K, so our vertex is 2, 4. Okay, so let's go ahead and put that on our graph. We have 2 for our x, positive 4 for our y. Our a is positive 1, so we can just use our little pattern, up 1 over 1 on both sides. Up 1, 2, 3 over 1 on both sides. 1, 2, 3 over 1. Okay, so there is our original function. Okay, we're going to have to invert it, so let's go ahead and identify these coordinate points. So this guy is 0, 8. This guy is 1, 5. This guy is our vertex, 2, 4. This guy is 3, 5. And this guy is 4, 8. Okay, so now that I identified all of those coordinate points, I can go ahead and invert them, literally switch them. So instead of 0, 8, it becomes 8, 0, which is going to be somewhere right there. Instead of 1, 5, it's going to become 5, 1. Instead of 2, 4, it becomes 4, 2. Instead of 3, 5, it becomes 5, 3. You can kind of see how it's starting to make that sideways shape. And instead of 4, 8, 8, whoopsie daisy, 4. And there we go. There's our inverted parabola. Okay, let's do that again. Okay, so again, for vertex form, we have our A, our H inside, K on the outside. Okay, so we can quickly identify our vertex. Change the sign on the H, so it was -2, now it's +2. Keep the sign on the K, -4. Okay, let's go ahead and graph that guy. So we have 2 down to -4. Now we just use our pattern, up 1 over 1 on both sides. Up 1, 2, 3 over 1 on both sides. And there's our original parabola. Okay, so we need to invert it to graph its inverse. So let's go ahead and identify these coordinate points. This guy right here is 0, 0. This guy is 1, -3. This guy is our vertex of 2, -4. This guy is 3, -3. This guy is 4, 0. Okay, we'll see if its inverted equation or function will fit on the graph. We'll see. Okay, so 0, 0 switches to be the same thing, so 0, 0. Instead of 1, -3, it's going to be -3 up 1 over there. Instead of 2, -4, it's going to be -4 up 2 right there. So you're seeing it's kind of going this way, bleeding into our other problem. That's okay. 3, -3 becomes -3, 3. And 4, 0 becomes 0, 4. So it kind of went off the graph, and I did a bad job connecting those guys, but we can see that it's kind of the flipped sideways inverted of our original function. Okay, beautiful. So our last two examples, we are going to find the inverse of each function. Okay, now the first step to finding the inverse, if you remember, just rewrite this g of x, f of x, whatever it is on this side as y. Okay, y equals 2x plus 4. Okay, now comes our inverse step. I'm going to put a star by it. This is the most important. Just like we flip the x's and the y's here, same thing when we're solving. Our y becomes x, our x becomes y. So now we have x equals 2y plus 4, which we can then solve for y. Once we get y by itself, we'll have the vertex. Okay, so we know how to do that. We're looking at our side with our y. First thing I have to get rid of is this plus 4, so I'm going to subtract 4 from both sides. I get x minus 4, still have 2y on that side. Okay, the last thing I need to do to get y by itself, opposite of times by 2 is divide by 2. Okay, so now instead of writing y equals, which we are going to just to show, y equals x minus 4 divided by 2, what we want to write it started as g of x, we changed it to y. Well, now we have to change it back to g of x, but because it's the inverse, we actually write it as g little inverse notation equals that guy. And there we go. Okay, so let's do the same thing for number 10. Again, change g of x, whatever this is, just to y. In this case, it's g of n. So now y equals, and I'm just gonna change both of those n's to x's. I like x's better. Doesn't matter actually what variable you use. Okay, so I simply just change that to a y, that to an x, so it looks more familiar. Then comes the inverse step, the most important. Y becomes x, x becomes y. Okay, I'm trying to get y by itself, so there's only one thing I have to get rid of here, and that's the opposite of subtract 3, which is going to be to add 3. Okay, so y is all by itself. I just like flipping it around so that y is on the left. Totally okay. So we have y equals x plus 3. But remember, we want to put it back into that g of whatever notation. I changed it to g of x. So now we're going to rewrite it as g inverse of x is equal to this side, x plus 3. And there we go.